Here are the answers to lesson 8-6. State the domain and range of the function, then write each correspondence using ordered pairs. Here's question 1. There's a chart showing a correspondence between an activity and the calories burned doing the activity. Another word for correspondence is the word relationship. The chart shows the relationship between the type of activity and the calories burned. We're asked to give the domain and the range. So first, the domain. The domain is the list of all of the items that start the relationship. In this case, it's the list of activities. So your domain is the activity jogging, the activity swimming, the activity tennis, walking, and bicycling. That list of 5 activities is the domain of this correspondence. Now the range. The range is a list of the second items in the chart, the things that are related to the different activities. In this problem, the range is the list of calories burned. 210, 270. Notice you have another 210. You don't need to list it twice. 120 and 330. Now we're asked to create ordered pairs. So show the relationship between an activity and its corresponding number of calories burned, not in a chart, but using ordered pairs. So the first activity is jogging, and when you jog, that burns 210 calories. The second activity is swimming, and that's associated with 270 calories. The next ordered pair is going to be the activity tennis, paired with 210 calories. Then walking, paired with 120 calories. And finally, the fifth ordered pair is bicycling, paired with 330 calories. Here's the same information from the chart, but shown using 5 ordered pairs. Now, number 5, the same directions. The first thing we're asked for is, what's the domain of the correspondence? What are all of the items that are first in the chart? That would be the different years. So 1940, 1950, 1960, this list of items are the domain of the correspondence. Now the range. The range is the list of second items in the relationship. That's the costs. So the 30 cents, the 60 cents, and so on. Now we're asked to take the pairs from the chart and write them as a set of ordered pairs. So 1940 is paired with 30 cents. 1950 is paired with 60 cents, and so on. Now page 377, written, number 5. What we're asked to do is graph number 5 above. So make a graph of those ordered pairs. Here is the y-axis, as straight as you can make it. Here is the x-axis, as straight as you can make it. Notice that I didn't make an XY grid that shows the other quadrants because I don't have any negative numbers. Now, the domain is given along the x-axis. So across the bottom is where you're going to list the elements of the domain. If the origin point is given the year 1900, then you can decide what to count by. This could be 1910, 1920, 1930, 1940, 1950, 1960, 1970, 1980, and 1990. The x-axis is showing the year. Now on the y-axis, we'll do the cost. Looking at the different numbers within the range, I see the lowest value is 30 cents. I see a 60 cents. I see the highest value is $5. I want to decide how far apart to space the marks and what to count by. I'm going to put a mark here and say that that's $1. So that amount of space can be duplicated, and here's $2, $3, $4, and $5. My y-axis is showing costs. Now the graphing. In the year 1940, it's 30 cents. So 30 cents is approximately right here. Remember that this height is for $1. Now in 1950, it's 60 cents. So twice as high as what I did for the 30 cents. I think that's about 60 cents. Remember that this level on the grid is $1. In 1960, I want $1.25. And so I think that's about right here. Remember that this height on the grid is level with $2. And this was $1. So I want to be $1.25. I want to be about 1/4 of the way up from the $1 to the $2 line. In 1970, I want exactly $2. So straight above the 70, put a dot at the level on the paper that lines up with $2 on the y-axis. In 1980, I want $3.25. So right here is level with the 3. Here is level with the 4. So $3.25 is about right here. And in the year 1990, it's $5. So straight above the 90, all the way up to the height, level with the $5 on the y-axis. Now it says to draw a broken line graph. What that means is you connect the dots with straight segments. Don't round it off and make a curve shape. Actually do straight segments. So in between here, here's a segment, and then to here, and then to there, and then up to there, and then up to there. Here's the graph. Now number 7, using this graph, estimate the cost of a movie in the year 1955. So find 1955 along the x-axis. It's exactly halfway between 1950 and 1960. Go straight up until you reach the blue line. Where is that dot? What is the height of the dot on the y-axis? It seems to be a little bit below the $1, so give it your best estimate, maybe 80 cents or 90 cents. So my estimate in the year 1955 is that a movie cost about 80 cents. Now what about in the year 1975? Find where 1975 is along the x-axis. It's going to be right here, halfway between the year 1970 and the year 1980. Now go straight up from that spot. Don't go slanted. You got to go straight up, and you'll hit the blue line. Now, what is the y value of that dot? So now go straight over towards the y-axis. About what dollar value do you think you're at? Well, it looks to be more than $2.50. It's not all the way up to $3, and so give it your best estimate. I think it might be about $2.70. Okay, now we're reviewing the stuff from the other day. So write the equation of a line if you know the slope and the y-intercept. If you know the value of m and you know the value of b. The equation follows the pattern y equals mx plus b. And we know this number and we know this number. So the answer is y equals negative 3x plus 4. Now number 8, we know the value of m, but we don't know the y-intercept. So we want to find the y-intercept. If the ordered pair 4, 1 is the solution to the equation, then the 4 is a value of x and the 1 is a value of y that solves the equation. Y equals mx plus b is the format. For y, use 1. For m, use 3. For x, use 4. And leave the letter b. So 1 is equal to 12 plus b. So b must be negative 11. Now we can write the answer. Number 18, we want to write an equation of a line that goes through these 2 points. This one right here is the y-intercept. Because the y-intercept is a point on the y-axis, it will have an x-coordinate of 0. So the b is 3. But what we don't know is the m. So let's find the m using the slope formula. This is x1 and this is y1, and this is x2 and this one is y2. So negative 1 subtract 3. And 2 subtract 0. This is negative 4 over 2, which reduces to negative 2. Now we can write the answer. Now number 30, write the equation of a line that touches the y-axis at negative 5. That is, it touches at 0, negative 5. And it touches the x-axis at 3. That is, it touches at 3, 0. Now, do we know the value of b? Yes, we do. The y-intercept is negative 5. That's the b. We don't know the m. So let's find m, the slope. How are the y-coordinates changing? From negative 5 to 0, it has increased by 5. How did the x-coordinates change? From 0 to 3. It increased by 3. The slope is 5/3. So the equation is y equals 5/3 x minus 5.